Okay. Sure. So given this function, or they can simply write the given the sigmoid function, which is often referred to as the logistic function in ML. What is its derivative equal to? Right. We need to find out the derivative, and it is given in the form of f of x. Right. So we will try to find the derivative such that this you can say this form of f of x 1 divided by 1 plus e to the power minus x is retained, right? So that we can convert it back to f of x. So here they have asked just the first derivative. So let's try to find the derivative. I guess I have the answers. Have I opened it? Calculus exercise, no? One second. Sorry. I was going through these notations and everything. So, same subject one, calculus exercise, algebra calculus exercise. This one. Yes. Rotate clockwise, rotate clockwise, rotate clockwise. Yeah, we are good. So, given this function, this is nothing but the sigmoid function. So given sigmoid function, we need to find out the first derivative, right? So you can write, you can solve it in two ways. You can convert this function in this form also, because e to the power minus x is 1 upon e to the power x. So you can write this as way also. And here it is like f of g of x, right? If you think intuitively, so it is 1 upon x kind of thing, right? If you think 1 plus e to the power minus x is nothing but capital X or capital Y, then what is the derivative? It is nothing but minus 1 by x square, right? Minus 1 by x square. So I have just taken the derivative of 1 by x, this thing first. So it is minus 1 by x square. Then I need to take the derivative of the sub part, this y. So derivative of this part would be 1, derivation of 1 is 0. Derivation of e to the power minus x, right? So here we don't have the pure function, right? E to the power x. So what is the derivation of e to the power x? Similarly, right? E to the power x only. Now I need to take the derivation of x again, right? Because here again I have one more function, minus x. Minus x is also function, so I need to take the again derivation of minus x. So it is minus 1. So the answer we get is 0. See, minus 1 multiplied by minus 1 is plus 1 e to the power minus x divided by 1 plus e to the power minus x square. Now f of x is given as 1 divided by 1 plus e to the power minus x. So what is e to the power minus x? I am just taking this as a subject. So e to the power minus x would be 1 upon f of x minus 1. That is 1 minus f of x divided by f of x. Why we are doing this? Because in options we don't have anything as like this answer. We don't have this answer. The answer is in form of f of x, right? That's why we are converting everything. Now there are like so many ways you can do it. You can just partition, you can divide this in two parts and then put the value of f of x, or you can follow this also. So f of x square is nothing but 1 divided by 1 plus e to the power minus x square. Why I'm doing this? Because I have this term here, right? So this is nothing but 1 divided by this. So it is f of x square. And I converted this thing into 1 minus fx and divided by f of x e to the power minus x, right? So I will put this thing and f of x square into the equation again. So this f of x and this f of x will cancel out, and what I left is 1 minus fx into fx, right? So the toughest part was this. This is like easy. And how to approach this problem is, after seeing this equation, try to solve like in parts first. Try to solve one by one and then put all the value back into the equation. Then you will get everything, correct? Then you will get the answer. And say this differentiation you can do in another way also. If you prefer the way that secant sir follow is, just take the lowest function, lowest order function. So the lowest possible simplest function is minus x. So what is the differentiation of minus x? Minus 1, right? And then what is the then just go one step one step you can say backward. So we have e to the power minus x. So what is the differentiation of e to the power minus x? E to the power minus x only, right? Now let's go like one step further. So this is only one function, 1 plus e to the power minus x. 1 is 0 only, right? Now what we need to do, just go again one step backwards. So we have the third function, 1 upon x. So 1 upon x, the differentiation is minus 1 by x square. So multiplied by minus 1 divided by x square, 1 plus e to the power minus x square, like this. You will get the same answer, right? So there are two ways. This is the toughest part actually. Correct? I guess the idea is clear, right?
Mayur,
Yes.
Mayur, on the equation that you had, I mean, where you had written or, then you had written e raised to x upon e raised to x plus 1. So there, can we use this quotient rule and so on? Because I was trying with that. No, on the top, on the top.
Here.
Yes, near or.
Here. You can derive this equation from here also.
Ashok, I mean, would you mind explaining that to me? Because I was trying with that rule, but somehow I was not able to derive it.
See, here what will happen is we need to apply the quotient rule, right?
Correct.
Then things will be messy actually.
So that was getting tougher.
Yes.
Mhm.
And see, here we have just one term, right? E to the power minus x here. And here we have two, like in
Two terms.
denominator and numerator, we have function. So if you apply the quotient rule, you can get the answer for sure, but it would be tough actually. And I will try it. Like after the session, I will share the photo. Right?
Okay,
Uh,
okay. So you
I'm sure
try
it
it.
is possible.
Mayur, can't we use chain rule here for solving this? One
Chain
upon
rule
one
for
plus for getting the derivation for this
we have just
equation.
one variable. No, how can we use chain rule? I'm not sure. Chain rule is something that yeah, we have two variable and then we can apply the chain rule, right?
Like fx is there, right? Df by dx. So we can take df
Actually,
of, yeah.
you might be mentioning about U by V rule.
A by B rule, na? Quotient rule, I guess you are referring. Yes, quotient rule you can also apply.
Chain could also be applied. I mean, that is chain is nothing but U into V, right? So both
Yeah.
can be applied. The result will be same.
Yes, okay, product rule you're talking about.
Yeah,
Yes.
that's
We
what.
can apply product rule, yes. There is no problem in it.
There are multiple ways to solve it.
Uh-huh. Correct. I guess in solution the way would be different, I guess. Okay, they have not given the solution. Funny. Correct. But the idea is like after getting the derivative, you need to break it into parts so that you are substituting everything in terms of f of x, right? Then and only you can get this answer. Correct. So in here I had two parts, one divided by 1 plus e to the power minus x square and e to the power minus x. So what I did is from this equation I get what is the value of e to the power minus x, and here it is trivial, like 1 upon e 1 plus this term square is nothing but f square x, right? F of x square. So it is just about substituting everything back into the equation, correct? Okay, let's jump on to next question. I will try to solve this using this term also. It is possible. Okay, let's have one more. Okay, where the curve represented by f of x equal to y equal to this ln of natural logarithmic of e to the power 2x plus 3 intersect with the x-axis and y-axis respectively. Now, here we need to remember one rule. If you have the logarithmic, any log base a, and again if a to the power something, a to the power x is given, then it is equal to x, right? This term and this term should be similar. So here the base is e, natural logarithmic base is e, and I am having e to the power 2x plus 3. So this is nothing but 2x plus 3 only, right? So now we have the simpler equation, y equal to 2x plus 3. Now they are asking like if, at which point it intersect with x-axis and y-axis. So just put y equal to 0, then you get x equal to minus 3 by 2. And if you put x equal to 0, then you get y equal to 3. So this is the answer. Correct? Because this is the equation of line y equal to 2x plus 3. So you just need to put x equal to 0, then y equal to 0. Then you can get the answer. Correct? But this rule is important. Right? Log base a and a to the power x is nothing but x only. Correct? Okay, let me clear the screen and okay, next question. Okay, limit
Equal to
extend to
0 to
infinity. Yes, this was tricky actually, but from mathematics only, pure mathematics.
Hi Mayur, can you hear
Yes,
me?
yes.
Uh, in the
In the now you are not audible. I guess you are on mute, Srikant.
no. Can you hear me now?
Yes, yes. Tell me.
I'm not on mute. Can you hear me?
Yes, yes. Go ahead.
Yeah.
Hello.
Okay.
Am I audible, guys?
Yes, Mayur, I can hear you.
Yes, yes,
Even
you
I
are
can hear
audible.
Shrikant as well. Yeah.
Correct. But the
Srikanth, go ahead.
Shrikant, go ahead.
Ask him whether he want to ask something or not.
yes, Srikant. If you want to ask something, please type because I'm not able to hear you actually. Uh, at start the
Mayur, please
voice was a
continue.
bit low. Now I can't hear. Huh?
He is saying to continue. He just messaged
Mayur,
me.
you can continue.
Okay. No
Yeah.
problem. No problem. Okay. So the next question here, here it is a pure mathematics question, nothing else. Here we need to find out limit x into infinity, right? And whenever we have this kind of a question to the power infinity, we need to convert everything in 1 upon x to the power something, right? If we convert everything into this, then our this thing is our problem is very easy. Why? Because 1 to the 1 upon infinity is 0, right? So given equation, if you can convert your terms in 1 upon x to the power n, then it is really easy to solve. So what we will do is, here like we need to take the highest degree polynomial from denominator and numerator. I'm just giving the generalized rule, and divide denominator and numerator by the same. So here the highest degree polynomial in numerator and denominator is x to the power 4, right? So what we will do, we will divide both denominator and numerator by x to the power 4. Then what will happen is, where is my arrow? Then what will happen is, let me open it now. Question number 3. So when I divide by 1 upon x4, divided by x to the power 4, this would be 3, this would be 2 divided by x squared, 3 divided by x cube, 12 divided by x4. Similarly, I will have only 2 here. Now when this limit x to the x is like x tends to infinity, this term would be 0. 2 divided by x square would be 0, to 12 divided by x4 would be 0. So anything like 1 upon x to the power n would be 0. So this term, all these three terms would be 0. So what I left is nothing but 3 divided by 2. So the answer is 1.5. Correct? So basic, you can say this thing, rule, this rule, limit rule. How to solve when you have infinity, like x tends to infinity. Correct? Next, okay. Question number 4. Now we know like what is this. This is Gaussian, right? And after knowing this question, and I guess we have one more question. Question number 7. Let's take question number 7 first. Sorry, let's do it in order because we can't. Now it is trivial. Let's say how f of x is nothing but 1 upon this sigma under 2 pi to the power something something something, right? This is Gaussian rule. right? This is PDF of Gaussian, right? Now mu sigma and pi are constant, okay, positive constant. Now what they are saying is, what is limit x tends to infinity f of x? When x tends to infinity, what is f of x, right? So from the knowledge of the Gaussian distribution, when the x tends to infinity, right, what is the value? It is 0, right? Now we know. And where it is maximum? At mu. When x equal to mu, it has the maximum value, and when x tends to infinity, it's 0. So from the knowledge of Gaussian distribution, we can directly answer this. But if you want to go like limit x tends to infinity way, we can do that also. Let me remove this. Yes. Okay. So how can we solve that? I guess I don't have that. I have here. Okay. So limit x tends to infinity, f of x is what? So see here. I guess my answer is wrong. No, okay. Here it is good. It is right. Now, when x tends to infinity, this is constant, right? 1 upon sigma 2 pi. Now, and where is like variable? So variable is there in e to the power this. Here we have only variable x minus mu divided by sigma. Correct. Now if we figure out what is the value of this power a to the power, what is the value of this x minus mu by sigma, or it minus 1 by 2 x minus mu by sigma square, then we can definitely say like what is the value of f of x, because this is just a constant term, positive constant term, right? So what we will do, we will just check limit x, when limit x tends to infinity, what is the value of minus 1 by 2 x minus mu square. Now what happen is, when x is infinity, right? So infinity minus mu divided by sigma would be plus infinity, because this is some small constant, positive constant, mu is small, right? So x minus infinity minus something is infinity. Then I have division, so infinity divided by some sigma is also you can say this infinity. Now I have this negative term, right? So negative minus 1 by 2 into infinity, so it tends to minus infinity. So now I know, let me take this thing, this value is nothing but minus infinity, correct? And e to the power minus infinity is 0, because e to the power minus infinity is nothing but 1 upon e to the power infinity, and 1 upon e to the power infinity is nothing but 1 upon infinity or 0, correct? And 0 multiplied by some positive value is again 0, so f of x is equal to 0 when x tends to infinity, correct? So this is how you can solve it. Just concentrate on the term where you have this variable, this x variable, right? Because everything else is nothing but the constants, correct? Okay, so let me clear this. Any doubt, guys, or we can move on to this Uber loss? I guess Uber loss. Yes, this is okay. Next, and let's solve the last question also, because on the same pitch. So we have this f of x again, this PDF of Gaussian Gaussian distribution or normal distribution, where these things are constant, and what they are asking is where at what values does the maxima for this function occur, right? So they are asking about where is the maxima. So we know like at the mu it is maximum, right? From the bell curve, everywhere else it is less than this value, right? So let's prove it actually. So how can we do that? Question number 7. Yes, here we have. So we have this function, right? Just concentrate now, because we have so many things, so many characters. So we have this function, right? Now if I and to find the minima and maxima, we can if you need to find minima and maxima, just take the differentiation. First differentiation, equate it with the 0, then find the second differentiation, correct? So if I take the first differentiation, it would be say this is constant 1 upon sigma by 2 pi. So I just put it as it is. Now what is the differentiation of e to the power x? Similar, right? E to the power x. So I have written this e to the power x as it is. Now this is not pure function, right? It is a function of function, like that. So I need to take the differentiation again, differentiation of this thing, right? So if I take the differentiation of this thing again, minus 1 by 2, sorry, this thing minus 1 by 2, this thing, then what happen is minus 1 by 2 sigma square is constant, sigma square is constant, so I have just taken the constant as it is. Now let's take the differentiation of x minus mu square. So what is the differentiation of x square? So it is nothing but 2x, correct? 2x power 1. So the differentiation of x minus mu square is nothing but 2x power 1, and I need to again take the differentiation of x minus mu, because it is again not constant, right? Sorry, pure function. So x minus mu would be again 1, right? So that's how we just take the from outside to inside, and we will go go into the depth there where we have just x left, correct? So that's how you just get the differentiation of f of a f dash x, and this part is nothing but fx. And this part, if you think, you can write it as this 2 and 2 will cancel out, and x minus mu minus of x minus mu divided by sigma square, right? So this is differentiation. Now I need to end and let's calculate the f double dash x first. Then we will try to make this equal to 0 to find the minimum and maximum, right? For the Gaussian distribution problem, can you explain the simple approach again? Sure, Bhavani. Sure. Now let's take the second differentiation. Here we will use the product rule. See, now we have the one this one. Let me clear it. We have the one function here and the second function here, right? F of x and g of x. Now how can we apply the product rule? So keep the first as it is, take the differentiation of second one, take the first as it is, take the differentiation of second one, plus take the differentiation of first one and take the second as it is. So f of x as it is, and if I take the differentiation of x minus mu by sigma square, so 1 by sigma square is constant. X minus mu, if I take the differentiation, it would be 1 minus 0. So 1 multiplied by this minus, so it will be minus 1. So this is f double dash x, correct? Let me remove everything and let's go further. Now for the optima, what we need is f dash x equal to 0. Yesterday we discussed, right? The differentiation would be 0 at the maxima or minima, basically optima, right? Which question is this? The seventh one. 3.22 had 7 question, Abhishek.
Oh, for me it shows only 6. I don't know. Okay. I don't know.
Because you know this Gaussian distribution in advance, right? So they didn't want to bother you.
Oh, no, not like that. I still see only 6 for me. Like question 6. The last one is that Cuba lost one. That's why I was like, where is 7? Okay.
Oh my god.
It's okay.
What kind of hard coding they have done? I don't know.
Okay. It's
Cool.
fine. Continue.
Sure. So to find the optima, we need to equate f dash x equal to 0, right? Normal standard procedure to find the minima maxima. So f dash x is nothing but minus x by mu sigma square f of x equal to 0. Now fx is always greater or equal to 0, right? Because everything is positive and everything, right? So to be this equation equal to 0, x equal to mu, I need to take x equal to mu minus mu would be 0. So this whole thing would be 0. So x minus mu equal to 0. So x minus mu is optima, right? So it is optima, not minimum, not maxima. So actually you can directly go with option D. You don't need to check the last thing, f double dash x, second derivative, because we don't have none of the above, right? And anyway it would be minima or maxima, correct? So I need to now check what is the second derivative, right? What is the second derivative now? So if I take the second derivative, x equal to mu, so I will put x equal to mu here. So this term would be 0, mu minus mu would be 0, this second term, and this term would be f of mu divided by sigma square minus f of mu by sigma square, right? So this is 0, mu minus mu is 0, so this whole term is 0, So I have just left with this negative term, negative f of mu by sigma square. So my second derivative is negative. So what is the meaning of second derivative is negative? That means f of mu is maxima. Yesterday we discussed this, right? If second derivative is negative, that means the function will start decreasing. The second, this first derivative will start decreasing from the hill. That means we were at the maxima, we were at the top, correct? And yes, there was a query like what is the explain the simple approach again. So see, uh, we were asked for this thing, right? This function we were given f of x is this, and now we know like this is the PDF of Gaussian normal Gaussian distribution or the normal distribution. And if you draw the Gaussian distribution, it will look something like this, right? It would be sorry, it will start falling, and here it will also start falling. It will be maximum at x equal to mu, right? So this is mu. What is the normal distribution? That means in your population, most of the observation is near to your mean deviation, mean, you can say, value. So the height you can observe is like almost average, right? 5.5 to 6.2, like that. And it is less chance that you find someone with the just 2 feet height or 3 feet height, right? Or 8 feet height, correct? That's all about these things. And from this knowledge we can directly say the maxima for this function is at mu, x equal to mu. So we can directly mark this, right? No need to solve first differentiation, second differentiation, or differentiation at all, correct?
Mayur, if in exam it is asked to get the minima, maxima we understood.
We solve it
They
already, right?
they might ask minima as well this time.
Minima is
Uh,
0 now. When x tends to infinity, it's 0.
okay, okay, yeah.
Correct? When x tends to infinity, it's 0. And actually, see, at x tends to infinity, it is 0. X tends to infinity, right? So using this differentiation, we can't solve it, actually. Correct?
Okay.
Okay, where were we? So this is hinge loss. Okay, so given a function f of x max of 0, not hinge loss. Yes, this is hinge loss. 1 minus x.
This Venkat.
Sorry.
Yeah, Mayur, you are able to hear me?
Yes, yes, a bit low audio, but yes, I can hear you.
Yeah. So, how can the minimum be zero? Like the question I have.
It at infinity it would be 0. So it won't be like 0. Like if you put any value of x, you will get some value. If you put even x equal to 1,000 or 1 lakh or 1 crore, you will get like small probability, right? 0.000 something like that. But you won't get 0. But when x tends to infinity, then and only it would be 0. We just prove it here, right? In the question number 4. When x tends to infinity, it would be e to the power minus infinity. And e
Yeah,
to
yeah.
the power minus infinity is 0. Correct? So
Yes,
there
yes.
is a like small probability, like it is not always like you can't say, okay, I won't have anyone in the earth like with the 1 feet height or like 10 feet height, right? There is a
Yeah.
like very little probability,
Okay, okay, okay.
correct? Okay, so given a function f of x equal to max of 0 or 1 minus x, where max AB computes the maximum amongst the two values A and B and returns the maximum amongst them. Okay. At what value of x is this function non-differentiable? Right. So when function is non-differentiable, when it is not smooth, when it is changing the value, when it is not defined. Right. At minus infinity is also 0. Yes, yes, Singh, you are correct. Uh, Max of 0 or 1 minus x. So how to solve this? So we can directly draw this diagram, right? So how it will look like? So max of 0 and x. So what will happen when x is equal to 0? When x is equal to 0, so what is the max between 0 and 1? So 1, right? So we will get 1. When x equal to 1, what will happen? 1 minus 1 would be 0. So I will get this thing. When x equal to 2, what will happen? 1 minus 2. would be minus 1. So if whatever the value I take greater than 1, this value would be negative. So I will always choose 0, right? It is maximum between 0 and negative value. So it would be always 0. So after this, the function would be something like this. Let me change the color where I have, right? So it will be something like this. From this, it would be looking something like this. And when I take x equal to minus 1, then what will happen? 1 minus 1 minus 1 minus minus 1 would be plus 2. So I will get 2. So this. So it will look something like this. Hinge loss, right? Basically, we have this 0 maximum of 0 1 minus zeta. This is hinge loss. Thanks for confirmation. So where this function would be non-differentiable, then at this point, because this function is changing the shape suddenly, right, abruptly, and you cannot draw like one tangent here, you can draw so many tangent here. That means geometrically, if you think, you can draw this tangent, you can draw tangent like this or tangent like this. That means it is not differentiable, correct? So at x equal to 1, it is not differentiable. The answer is D. Last question. Yes. This is Uber loss. Now, what we are given is, see, the equation is very, you can say, deadly, but if you put this, how to pronounce this? Delta, na? It is del or delta. Delta maybe. Delta equal to 3 and A equal to 4, if you put, then this would be really easy. So, how to read it? L delta of A is half by A square if mode of A is less than delta, right? When A is less than delta, basically, mode of A. Otherwise, we need to use this formula. Say a delta mode of A minus 1 by 2 delta. Now, what we need to calculate is differentiation of this function with respect to A, and A equal to 4, and the constant delta is given as 3, right? So if you think intuitively, we need to calculate at A equal to 4. So at A equal to 4, we can solve this in two ways. We can directly put delta equal to 3 equal to 4 and then try to solve it. But let's not do that and try to solve it. But see, this case is not the what I want to make point is, this mode A 4 is not less than 3, right? So we don't need to consider this 1 by A square anymore, right? So our equation is L equal to del of A minus half delta, correct? See, 1 by 2 A square, we don't need to consider it anymore, because our mode A 4 is not less than delta 3, right? If A was 2, then we need to consider half A square. Then this condition, this equation we can ignore, correct? So let's see how we can solve that. Algebra calculus, where it is. Yes. Now mode is not less or equal to delta, so we will use this del multiplied by mode A and half del square, right? So del multiplied by del is del square or delta square, right? So now I need to take the differentiation with respect to A. So with respect to A, if I take the differentiation, then this term would be 0, half delta square, right? This would be 0 because there is no A here. And what would be the differentiation for this? Delta is constant, delta as it is. Differentiation of mode A divided by dA. Now I need to put A equal to 4 because we need to find out the differentiation. We know the equation now. We just need to put A equal to 4. So if I put A equal to 4, then it would be, sorry, 1 second, dA. So if I put A is greater than, you can say 0. So D of mode A would be again A. So dA divided by dA. So if I take the differentiation, then it would be 1, right? So 1 into delta minus 1 into delta minus 0. So the answer is delta. So whatever the value of A you take, the answer would be always delta 3. Whatever the delta you have, right? So if A was equal to 5, again I would have the answer 3, because in this equation I don't have the value of A, correct? And okay. Yes, just keep in mind. I was just going to write this, And why I have highlighted I have highlighted this, because you can't take mode a equal to a, right? Mode a equal to a you can only take if a is greater than 0. If a is positive, then and only mode a is equal to a. If a is negative, then mode a is negative, right? If mode a is negative a, if a is negative, how? If a is negative, let's say a equal to -5, then what will happen is minus minus 5, right? So minus minus plus. So that's how this mode is defined. So d by dx, so the differentiation of x mode x is equal to 1 if x is greater than 0, and it would be -1 if x is less than 0. That's why I didn't write directly 1. I just wait for one step, then I write a equal to this term equal to 1, because a is 4 greater than 0, actually positive integer, positive number, right? Let me clear this. And
Mayur, if the value of a was 3, so how would we solve this?
a would be 3, then we need to consider this formula half a square. Let's take that na, as exercise, no
Yeah,
problem.
yeah.
Sure. Let's say a equal to 3 or a equal to 2, anything, right? If this condition is satisfied, if this condition is satisfied, I don't like this color. Yes, if this condition is satisfied, then we need to take the formula, this formula. Then what would be the case? Let's solve it. So the differentiation of this function, loss function, with respect to a would be half. And what is the differentiation of a square? 2a, right? Then the answer would be a. So the answer would be 3 or 2, whatever the value you have, right? So dl by dA would be a, 1 by 2 a square, and differentiation of a square is 2a. So 2 and 2 will cancel out. So the first differentiation of loss L dash equal to a. Yes,
Yeah.
then the answer would be 3. Correct?
Sure. Yeah.
Uh, Let me clear this. What is the name of this loss function? Uber loss. Uber. Okay, I guess all the questions are finished now. What is the time? Oh, 10:13. No problem. Okay, and we don't have any more assignment on calculus, right? This is the one only. Okay. No solved
Do, do,
example or anything.
do you have any good site where we can practice more?
Definitely, let me share it. Calculus limits as infinity, yes. So if you want to uh, like solve some examples and with the formula, if you are looking for, then this is the best site I come across, this Paul's online math, because he has taken like in one page there would be only one concept: limit x tends to infinity or minus infinity. So all the formula, some examples, solved examples, and some this thing
Mayur, can you ping it
exercise.
in chat
Sure,
window?
sure, sure. There is not beautiful side, but content is good. You can go to this thing, calculus 1, right? Brilliant is brilliant, actually. Yes, brilliant.org is also good. Definitely. Okay, so let's jump on to our main thing. Uh, so on 27th, we have planned to cover this insertion sort, big O, theta, omega, this time and space complexity, basically. So let's see the theory first. Bird eye view, basically. I won't go into detail. So let's see the theory first. Then we will go in directly jump onto exercise. So notations. Yes. This is the notes that I said actually today. Actually at 8:30 maybe. So, why we need actually these notations is to solve one particular problem. We can have so many algorithms, right? To solve this sorting problem, we have insertion sort, merge sort, heap sort, so many things. So, which method to use, which algorithm to use, right? Which solution is best? So, how to like compare? How can you compare these two algorithms? right, on basis of time and memory. So it is called the, you can say that, asymptotic analysis. Actually there were a priori, and if you want to go into detail, just to follow this Professor Khalil's, you can say, notebook. uh, there we had a priori and posteriori analysis. I can't actually pronounce it. So let's start with the topics, this insertion sort. Then we will try to find out what is the order and what is it, o omega omega o, like that, theta, right? So what insertion sort is? Insertion sort is nothing but it is like how you sort the cards. So we start with the first element and put it we go through all the elements and we put one by one in the sorted array. So if I take 5, it is trivially sorted, right? So I put 5 as it is. I take 3. Now what is the good place for to put the 3 before 5, right? So I just put 3 here. If I take 2, then I will compare with 5. Okay, it is less than 5, just go ahead. It is less than 3, just go ahead. I will put 2 here. So I'm just taking this element one by one, and I'm just I'm just you can say inserting into the proper place, right, by comparing from the left hand side to right hand side to left hand side, right? So if I take 7, if I take this one, what will I do? I will first compare with 5. It is less than 5. Just go like one step left. Compare with 3. Then compare with 2. Again, it is smaller than 2. Just put, right. Just insert 1 at the first index, because we don't have anything to compare now, right? So this is called the insertion sort. I am just taking the assumption that you have just gone through the theory, because target is to solve as many numericals possible, right? Okay, so what would be the best case if the array is sorted, right? Already the work is done, array is all sorted in ascending order, right? Uber loss is used in rex. Okay, regression is stated by efficient, yes. Okay, and the worst case is nothing but if array is like in the descending order, right? If the array is in descending order, then it would be the worst case, correct? We will see like this worst case possible. Worst case, I guess we have this thing also, this numerical also, worst case time complexity. Okay, and yes, in case of MSQ, this is our favorite topic. Some definitions, terminology alert. So in place sorting, what is the meaning of in place sorting? In place sorting is nothing but we are given the array. Let's say we have this array, and we don't need any space, auxiliary space, that we need to copy this array into that space. Then we divide them, then we connect them, and then we give the answer. If given this space, if we are taking like one or two or three, let's say, space, extra space, but order of one, right? Given the array, if we are sorting in place, that means at that memory location only, then it is called the in place sorting. Insertion sort is in place sorting, right? Because we are just shuffling these elements in the array itself, right? We are not copying the array somewhere else and then trying to do this, trying to what you can say, sorting it, right? So it is called the in place sorting. That means sorting array without copying it and modify given array at the original place. So what is the meaning of stable sort? So stable sort is defined as the this element. If let's say I have a repeated element, right? No problem, Abhishek, bye bye. So we have this table sort. Let's say we have one array and two elements are you can say repeating. Here 3 and 3 are repeating, right? If the position of this repeating element is not changed, right, the order, actually this order should not change, right? Because that means your sorting algorithm is not doing good, correct? So what is table sort? If I sort this array, so it would be 2 3 3 10 and king, 2 3 3 10 and king. These three of hearts is you can say the third position. It's before three of how to pronounce this asterisk, right? Then it is stable. If after sorting, if the position of these three of hearts and three of asterisk is interchanged, right, then it is called not stable. That means your sorting algorithm is doing overwork, that it is not keeping this thing repeating elements, correct. Let's and this can actually cause the problem also, that we are not going into detail, but this unstable, you can say, kind of sorting can create a problem if we have some you can say value assigned to this key, correct. Let's see what is the meaning of online sort. Online sort is nothing but we don't know these elements at like first place, right. We are not given this 10 2 2 3k. I will just give you 10. Then I will give you 2, right? So this data is arrival. So this is, if sorting algorithm can perform sorting on arrival of data, right? Then it is called the stable sort. So this can do, right? Insertion sort can do, right? Because we are just taking a value one by one. Let's say I just give you 6, you will just put 6 as it is, correct. Then I will give you, let's say, 5, then you will put 5 here. Then I give you 10, you will put 10 here. Then I give you, let's say, 7, then you will put 7 here, right. So insertion sort don't need this array at first place. The data can be arrived in this fashion, sequential fashion, right. So it is called the online sorting, correct. So these are some properties of sorting algorithm 1 2 and 3. They can ask some questions like uh, in given the insertion sort, which type of algorithm it is, in place, table, online. So both are all three are correct. Okay. uh, okay, that's all about this insertion sort. Let's talk about model of computation and notations. So why we need this order, why we need this small o, small omega, I am not going into detail. And why can't we just run the program and take the time, like what time it is taking to find out what is the time complexity. Yeah, it was like discussed actually. If you do that, let's say I have this Acer laptop, right. So if I run it here like 7 year old or 8 year old, right, if I make one algorithm, it is taking, let's say, 100 millisecond, right. And if I just copy it into like a GPU based system, higher, right, any Acer Nitro or something, then it will just take 10 millisecond. So you cannot. And if I just go one step further on the cloud, if I take higher and higher, you can say, configuration system, then it is possible that it will take just 1 millisecond. So you cannot compare the algorithm based on this. You can say time taken by the run time, right. That's why we need to compare the algorithm with some this asymptotic analysis. So this asymptotic analysis use 5 asymptotic notations, right. And it is nothing but the bound basically, right. So we have these three big, you can say, bound, and we have this small notation or little notation, right. So big O, big omega, and theta. Let's compare, and we have two small or little notation, that is small o and small omega, right. So what it is, see, if I have function f of n, right, and how it is defined is, let's say, big O is defined as, let's say I have function f, right, function f. It is said to be order of g of n if f is less than g multiplied by c for any c, right. This is for some c, not this is for every, right. For if I found out just one value of c, at least one value of c, such that after n0 for some value of n0, actually here it should be all after n0 for some value of n0, I need to find out one limit. After that my function is less than g multiplied by c, right, for all n greater than equal to n0. Okay, that was mouthful. Let me explain it in a diagram. So if I take one function, let's say 2n square, f of n is 2n square, right? Then I need to find out one g. So g is again n square, right? In c I am taking s3. So you can take any value of c greater than 2. So if I take 3n square, 4n square, or 5n square, doesn't matter. I just need to find out just one c. Right? If I multiplied by c into g, 3n square, it is greater than 2n square after some limit, right? After something, after some, you can say, is an after one, you can say point constant value, right here. Okay, now it would be clear. After this, see, before this limit, your g is less than f, correct? But after this 5, after the value of 5, n0 equal to 5, my g is greater than f, right? G is greater than f, then you can say f is order of g, correct? F is order of g. So your g is upper bound to f after one limit, because before the value of n0, I don't care much actually, right? Because the this is nothing but the, you can say, input parameter, input size, 0, 1, 2, 3, 1000, 1 lakh, right? So this is nothing but the size of an array, and this is nothing but the time you are taking, 50 millisecond or 50 nanosecond, 100 nanosecond, 150 nanosecond, like this. So if my input is very small, I don't care, right, how my function is behaving. So I need to bound my function after for the big value of n. When the input size of an array or input size of an, you can say, data set is very big, then you need to compare like how it is behaving, right? That's why we are having this kind of you can say limit. After this, after like n greater than n0, we just care, right? And we don't care if the value of n is less than n0, correct? So that's how this big O is defined, correct? Okay, so, and what is small o actually? So after this, after the discovery of big O, we need to care about this, we care about this c also, right? You can't take c equal to 4 or c equal to 3, right? If you take c equal to 3, your g would be less than f.
Mayur, it should be f less than or equal to g, right? For the
Yes,
big
yes,
O.
yes, yes, less than or equal to, yes, yes, yes. Here I have one problem, yes, correct. Because at this point n equal to 0, it would be equal to actually. So it should be less than or equal to, yes. In big omega I don't have problem, but this don't consider this definition, because this is not true actually. Here we have problem. Okay, no, this is for small o. Okay, no problem, there is no issue. See, here I have written f of n less or equal to c into g of n, correct? This is the definition for small o. So small o,
Oh,
it is
oh.
nothing but the small improvement in the big O notation. And what is that improvement is, you can take any value of c, right? So let me read the equation again. So what I'm saying is, in small o, you can take every value of c, you can take any value of c after this limit, after no, right? After one limit, your function would be strictly less than g. G multiplied by c, c is constant, g multiplied by c, right? So here I have this function f. This blue is the function f. Sorry, this green is function 4n square, 4n plus 2, right? Now if I take g is equal to n cube, right? So what is g? G is n cube. G is always function, don't confuse between 1 n cube, 0.7 n cube. This is not g. G is just n cube. So if I take g equal to n cube, I can take any value of c. If I take 1, 0.7, 0.5, just this limit would be changed. The limit will change, right? The limit of n0 will change. If I take let's say 1 n cube, so I'm getting this gray curve. So after 5, my g is always greater than f. If I take 0.7, c equal to 0.7 n cube, then what will happen? After 7, my this purple line is nothing but 0.7 n cube. It is greater than f, green line. And again, if I take smaller value of c, 0.5, then what will happen? After like 9, it will be again it will again or like you can say cross f, and it would be greater than f, this green line, right? So small o is nothing but you can say small improvement in the big O notation, that after NO for every value of C, for every value of C, your function is strictly less than G multiplied by C, right? Okay, this big omega is exact opposite of big O, right? So big O is the upper bound, small o is proper upper bound, right? It is always upper bound for F, right? For every value of C, so it is proper upper bound, and big omega is the lower bound. So here the again the definition would be same. For some value of C, you just need to find out just one value of C such that your function is greater than G. That means your G is lower bound, right? Because G is less than F, or F is greater than G, greater or equal to G, right? So this is lower bound. G is nothing but lower bound to F for some value of n. This would be always same for all these notations, right? After some limit threshold, I just care about the comparison, right? So let's see about this thing. Let me put it here. Big omega, so if I take F, right, for n square, so if I'm just taking C equal to just 3, now your G is lower bound to F, right? After n equal to 0, or n equal to, let's say, 0.5, your G is lower bound to F, your F is greater than G after this, right? After this, so, and at n equal to n0, it is equal to F equal to G. So that's why we are writing, for any value of C, your function is greater or equal to C into G of n, right? That's how we are writing big omega. And small omega is, again, as you have guessed, it's improvement in big omega. Now what we are saying is, you can take any value of C, and this condition would be always true. F is greater than C multiplied by G. So your G is always a lower bound to F for any value of C, right? So we don't need to choose the value of C, right? So let's see, does it work or not, right? So now I am taking the same function again, 4n square 4n plus 2. Now if I take G equal to G of n, the function G equal to n, now what happened? Now let's take C. I can take any C, right? 20, 30, 45, any random C. Now what will happen? Just this thing will change actually. The threshold will change actually, n0, or you can say K, right? This value of n0 will change, but after that your function will be always greater than your G, right? So your function is greater than this line, pink line, this blue line, and red line, correct? So that's how this small omega is defined. And what is theta? Where is theta? Okay, so theta is nothing but, you need to take the two variable, you can say two value of C1 and C2, such that your function is tightly bound. That means upper and lower bound by G, right? So do we have that thing? Here we have. So if I take F equal to 4n square 4n plus 2, and if I take C1 equal to 4 and C2 equal to 3, sorry, C1 equal to 3 and C2 equal to 5. Now what happened is, now this C2 multiplied by G is upper bound to F, and C1 multiplied by G is lower bound to F. That means the time taken by your algorithm is always less than C2 multiplied by G and always greater than C1 multiplied by G. That means we have tight bound to our function. The time of the algorithm it will take, right? So it is called the theta. Okay, and if you have, let's say, second degree polynomial, then your big O can be n square, n cube, n for anything. But your small o cannot be n square. It can be greater than 2 only. It can be n to the power 2.1, n to the power 2.2, right? Or n cube, n for n5. It cannot be n square, right? Because it is proper upper bound, right? And big omega would be n square, or if you take n, it is also like n is always less than n square. If you take root n, again it is less than n square, so you can take n square n root n like that. But if you're talking about small omega, proper lower bound, then you can't take n square. You can take n to the power 1.5, 1.8, 1.9, and root n, cube root of n, anything. And theta is always n square, exact bound. Right? So whatever the common term you have in big O and big omega, it is always theta. Correct?
Yeah, maybe can you repeat this thing? How we are taking these values?
Hmm. Okay. So given the polynomial a n square plus b n plus c, your big O can be either n square n cube. So it is nothing but upper bound, right? So if I take a n square plus b n plus c like this function is a n square plus b n plus c only, 4n square plus 4n plus 2. So this function can be upper bounded by either n square or n cube. If I take n cube, it will again upper bound, right? Or n to the power 4, because your n square, n cube, n to the power 4 will be always greater than n square, right? Whatever, however, the n square will change, your n square, n cube, n4 will change faster, right? It will be greater than you can say n square always. If you take n equal to 10, then here it would be just 100, but n to the power 4 would be 10,000, correct, like that. But small o is always you can say this thing, proper upper bound. You can't take n square. What happen if you take n square, right? You can't define it as small o. Why? If I have this function 4n square plus 4n plus 2, and if I'm saying, I'm just arguing, I will take my small o as you can say n square. Now what happen is, if I take and for the definition of small o, I can take any value of c. If I take c equal to 3, then what happen? Your f is greater than g, right? Right, and then you can't define f small o, because your f should be small than g. G should be upper bound, right? That's why we can't take n square, right? Because it is not true for all value of c. F less than g is not true for all value of c, correct? That's why we need to take polynomial greater than n square, n cube or n to the power 4 or anything. Okay. Similarly for big omega, it is lower bound. So you can take n square, right? Because we just care about for some value of c. So if I take c equal to 3 or c equal to 2 or c equal to 1, then it would be lower bound to 4n square plus 4n plus 2. So your big omega can be n square, but small omega cannot be n square, because it is the proper lower bound. So if I take n square and c equal to 1000, right, then it would be greater than f of n. Then it cannot be work as the lower bound. Right, the idea behind lower bound and upper bound is nothing but you need to compare, right, in the worst situation how your algorithm will work, right? And as we discussed like earlier, this upper bound is nothing but, let's say you are designing a game, and the time it take to run, like runtime complexity is something, right? You know the function. Now you want to recommend some you can say hardware configuration, like this much of RAM is needed, this much of SSD is needed, will it run or without GPU or not, right? So based on this upper bound, you can definitely say like my game will run with this resource. And if you want to say like minimum resource requirement, and if you want to say like for the best experience, you will use the small o, right? Because it is always greater than f of n. If it is n square, I am taking n cube here. Then you will say if you have 16 GB of RAM, it will run fantastically, right? If you want to run it on the highest setting, HD and highest frame FPS, then use this thing, right? That's why we need this upper bound and lower bound and everything, correct? Okay, it is 10:40 already. I am worried about the time. Let's see the order of function now. So the order of function is useful while solving the numerical, and yes, then we will jump into numericals. Order of function, the one is always good, right? The constant time it will take, whatever the value of input it will take the constant time. Let's say your program is just returning the first element of array, right? The array can be of size 1, size 10, or size 10 crore. It will take just 1 millisecond or 1 nanosecond, right? Constant time it will take. Just because it just need to give the first element of array. Correct? So it is constant time. Then logarithmic will come. More the log, better it is. If you have log n, it is greater than log n. If you have 3 time log. If you have 4 time log, it is all again better. Right? So more the log, it is better. Single log, then it will come the single log of n. Then the polynomial of log. That means log n square, log n cube, log f whole. This is power to log n, not n square n cube like that. Right? Then I have this thing n square c. This n to the power c and this n to the power x is different. Here the c is less than 1. What is the meaning of c less than 1? Under root of n, right? Under root of n is nothing but c is equal to 1 by 2. If I take c equal to 1 by 3, then cube root of n, right? So the under root of n, cube root of n, or fifth root of n, 1 by 5 or 1 by 6, then it is having more time than logarithmic. And how if we are going like in the right hand side direction, the complexity, the time, it will take more, right? More the time it will take. Then we have this small n, simple n, right? Then linear time, actually it is called the linear time complexity. Then we have n log n, n multiplied by log n. Log n is positive value, right? Always. So n multiplied by log n, and n is always greater than 1, because you can't have array of size 0. Then what is the meaning of running your code? Correct? If you don't have array, or if you don't have input basically, right? So n multiplied by log n. And why n multiplied by log n is greater than n? Because log n is positive. Then I have n square, right? Then n cube, then n to the power 4. So it is nothing but the polynomial n to the power x. Correct? Then I have c to the power n. So these are nothing but the monsters. It will like in some settings, if you have just a million record, it will run for 100 years or 200 years like that. So this is the worst case actually. C to the power n, that means 2 to the power n, 4 to the power n, 100 to the power n, like that. And at last I have factorial, n factorial. Correct? And n
Maybe there is
factorial.
also something log star, right? Log star, where does it lie?
Logstar is there in Wikipedia, but I haven't seen like use, and I don't know like where it is used.
Okay, okay.
Logstar is there. Logstar is, I guess, before logn, I believe.
Yeah, I guess it is smaller.
Yes.
But I don't even know like how what is log star. Like
What is
I heard
Logstar?
the first.
Basically, yes. Order of function. Big O notation. Yes. Logstar is there, I guess, and it is less than logn, I believe. Oh no, and logstar n is given. Only logstar n, I don't know where it is.
It should be above log n
Ah,
uh,
no,
because it is smaller than
only
n log n, right?
ah,
So it is smaller
only
than log n.
logstar n is not given. It is greater than n log n, so
Yeah,
it should be after log n basically, before log n, right? It
right,
should be
right, right.
third position, right? Oh, it is defined like this. Logstar n is defined like this. Cool. Where were we? Why it's not opening? Yes. Relationship between notations. Just read it once, because it is just to like memorize everything, mug up basically. There is nothing to learn from here. Transitive, reflexive, symmetric, or trichotomy, right? So it is just true for all notation. Transitive, reflexive is just true for big notations, and symmetric is just true for theta, and trichotomy is not true for anything. Correct? Nothing to learn from here. Just see this thing. Merge sort. Okay. I guess this kind of tree structure, I guess we will need in the recursion So tomorrow I guess we will use this. I said a Zam file with the meeting. Zam board. So can we write there or something? I don't know. Like yesterday also you said this, right? Okay, it is asking for access. Never mind. Okay, so this linear search, binary search, this will come under recursion. So tomorrow we will cover this, and this is just formula we need to remember. And yes, application also. We had the question also LCS. Yes. So tomorrow we will cover this recursion, and I guess we are good with the theory part, and we have around 45 minutes to finish the ASN exercise. Okay. Uh, let's take like 2 minute break, guys. Then we will jump on to the exercise 10.10. Meanwhile, like, do you have any doubt regarding these notations? Then we can take it up. We go, yes, 10.10. 13 or 12 or 13 question. How much were there? 7, 8, 9, 10. Oh, okay, 12. Just 12 questions we have. So I guess in 45 minutes we would be able to solve it. Cool. Uh, Meanwhile, let me try to play with that jam board. What is that? Request sent. Log star is iterated log. Okay. Just take a break. Yes. So where are we? We just covered this. Okay. Python. Just see all the notebooks that are shared in running notes. By applied AI basically. और तो क्या रह गया, ये हो गया, ये हो गया. Problems. Okay. So it is in our schedule. Problems on BIGO, theta and omega notation. If we are able to finish the mandatory exercise, then we are in good shape. Tomorrow, 2 hours straight, we will solve all the exercise problem. Today is Tuesday, Wednesday, Thursday, Friday. So recursion, then regex SQL. SQL actually basically not regex. We will cover. It is related to coding. And what else? Okay, so Wednesday, Thursday. So Friday and Saturday we would be solving this midterm and mock and everything. Correct. Wednesday, Thursday, Friday, Saturday. 4 days we have. So tomorrow recursion and dynamic programming. If something is remaining, we will cover it on Thursday, and we will see these SQL problems because we have so many questions from SQL. So it is most MP. And Friday and Saturday, 2 days, we will be solving mock 1, 2, and mid sem 1. Correct. Okay, sounds good, guys. Sorry for taking the break, but it was needed. Yes. Okay, so consider an array of elements given this 31, 41, 59, this. Number of iteration it required to sort the elements, right? Very nice question to start. So I guess yes. How many iteration it will need? So before looking anything, you can directly answer it. If it is having six, you can say elements, it will take n minus one iteration. Why? Because first element is always you can say trivially sorted, right? 31 is trivially sorted. We will start with 41. So if 41 is greater than 31, we won't swap it, right? We will then jump on to 59. 59 is also greater than 41. We won't swap it. 26, it is less than 59. Swap it. 41, yes. 31, yes. Just swap it. Put it into 26. So we will basically need 1, 2, 3, 4, and 5 iteration, right? So 5 iteration is needed. Good question to start. Okay. So, what is the best and worst time complexity of insertion sort? Right. So, it is nothing but best case is order of n. If everything is sorted 1, 2, 3, 4, 5, I am just comparing. I am just going through, like I am just making 5 comparison, right? And what is the worst case? It is order of n square. Why it is order of n square? Say somewhere I wrote it. I can't remember. Yes, here it is. See what happened is if we have like worst case is nothing but the every element is in descending order. So now what happened is if it is in descending order, I will just make how many comparison and how many swap I need to make, right? The iteration would be four, like 4, 3, 2, 1. Four iteration I need to make. So how many swap I need to make, right? So at 4 I need to make one swap with the 5 because it is less than 5. And how many swap I need to make it 3, right? So after first iteration it would be 4, 5. Now next I have 3. So I need to come. I will compare with 5. I will swap with 5 because 3 is less than 5. Now what I will do? I will again compare with 4. So 3 is less than 4. So I will again swap with 4. So I need to make the two swaps, right, with the 5 and 4. So here I need to make two swaps. Similarly, after this iteration, my array would look something like this 3, 4, and 5. Now I have 2. So I will swap with 5, I will swap with 4, I will swap with 3. So I need to make the 3 swaps now, right? Similarly, for fifth element, the 1, I need to make 4 swap. So how many swaps I need to make? 1 plus 2 plus 3 plus up to n minus 1, right? Because first element we don't consider because it is trivially sorted. Right, so sigma I to the power I1 2 and I minus 1. So if you solve it, n minus 1 divided by 2 into multiplied by n. So it is order of n square. N square by 2 minus n by 2 minus n. Sorry, minus n by 2. So it is order of n square. Correct. So the worst time complexity of insertion sort is order of n square. And if it is trivially sorted, I don't need to perform any swap. I just make two comparison. I will compare with 1, I will compare with this 2, compare with 3, compare with 4. I am done. I will just make n minus 1 comparisons and I am done. Correct? That's why the best time complexity is order of n, worst time complexity is order of n square. Okay. Next question. Yes. Where are we? Which question it was, like worst and best time complexity? Yes. What is the tightest upper bound? Represent the number of steps required to sort n numbers using n insertion sort. So it is order of n square. We just saw, right? What is the worst case time complexity? Actually, we jump on to question number 3 directly. So what is the worst case time complexity of insertion sort? If all elements are in descending order, it's order of n square. So it is nothing but the number of swaps it required, right? So these two questions are similar actually, 2 and 3. Question number 4, interesting. Okay. Sort the following function by increasing order of growth. For every pair of function f of n g of n is sorted, prove that f of n is order of g of n. Assume LG applies with log base 2. So LG is always log base 2. So we need to compare these four functions in the increasing order of growth, right? So the smaller first, then bigger, then bigger and bigger in terms of asymptotic, you can say, time complexity, right? So let's do it. So if you now we just need to look for some trivial answer. So this is trivial that okay, we need to compare this because these two are monsters, right? It is what it is called, not polynomial, what it is called, 2 to the power n, or 4 to the power n,
Exponential.
exponential, exponential, yes. So these two are exponential, this log n and root n. So log n is always smaller, right? So we know this is number 1, and after that this is n to the power 1 by 2, right? So this is number 2. So now we need to compare these two. So how can we compare that? So 2 to the power n, I don't know what is the value here. So 2 to the power log n, right? So every time when you are confused, just take log. So if I take log on both side, here log base 2 would be 1. So I will just have n here, and at this time, at this type, sorry, at this side I will have log n. Log base 2 would be 1, right? So n is greater than log n, right? So now this question mark is solved. So n is greater than log n, that means 2 to the power n is greater than 2 to the power log n, right? So this is number 3 and this is number 4, and answer is also number 4, number D, right? Log n root n, 2 to the power log n, 2 to the power n, correct? Easy peasy. Okay, now we have this thing. Here the answer was wrong, then they corrected none of this, they added this thing. Okay, now we have this 5 1 2 3 4 5, 5 this thing, and we need to so arrange this function into increasing order of growth rate, right? So there is nothing but big O. So how can we solve this? So if I, so what are the trivial answer we have? uh, this is 10 to the power n. Okay, so this is you can say exponential, so this would be at last. And this thing and this thing, these three are polynomial, right? And whenever you have polynomial, just observe the power. So here I have 1.5, here I have 5 by 3. 5 by 3 is nothing but 1.6, right? And it is 1 by 2, so it is 0.5. So 0.5 is greater than 1.5, and 1.6 is greater than both, right? So this is order, this is 1, and this would be 2, and this would be 3, correct? So this number we know. Now we need to compare rest of the things. So 10 to the power n, 2 to the power under root log 2n, and we will compare with this guy or this guy, right? Okay, so let's see how can we solve that, because I can't write everything. So let's jump on to the solution. So how can we make comparison now? And the answer is not given. So let's see like what is the correct answer. Okay. Sure. Yes, this order of function we know. Yes. So now how to solve this, right? So this thing we already know, right? This number we know, root n, then n to the power 1.5, 5 by 3, and then 10 to the power n. Now this we need to compare 2 to the power log n. When it will come? It will come at first, second, third, or fourth, right? So let's start by comparing with the first term. Now, when I compare 2 to the power under root log n with under root n, now what happen is, always take log, right? If you need to take 1, 2, 3, or even 5 time log, take log, no problem at all. So under root n can be written as n to the power half, and this is already in exponential 2 to the power root log n. So if I take log on both side, what I will get is 1 by 2. The this exponential would be converted into multiplication 1 by 2 log n, and under root log n multiplied by log 2. Log 2 is nothing but 1, right? So, and every time whenever you have this type of constant, just remove it, right? Just remove it. And we can definitely remove it because we have the flexibility to choose C in order in BIGO, correct? So whenever you have this kind of thing, this guys, you can say you can remove it. these constants. Right now, I need to compare log n and under root log n. So if you see, if I had something like this x and root x, so who is bigger? X is always bigger than root x, right? So I can directly write this. But let's solve it slowly. So log n can be written as root log n, and here I have root log n. So this root log n will cancel out. So I have 1 here, I have root log n here, right? So root log n is always greater than constant time complexity. Order of function will come into picture here. So you need to remember that order of function, right? So the root log n is greater than 1, correct? And if I just go to my root, right, कहाँ से start हुआ था, तो ये start यहाँ से हुआ था. So root n is greater than 2 under root log n. So after solving all this, we just need to see like where did we start, correct? So I know that this term, this guy 2 to the power root log n is greater than this. So it can't be at first place. So it can be at second place. So let's compare this thing now, correct? So, oh sorry, 1 second. It is less than root log n, no? So it would be at first place actually. 2 to the power under root log n would be at first place, because it is less than root n, right? And I don't have any option like a b c and any option given in mcq. That's why it is none of the above. We don't need to compare now, right? The answer is already we know, right? 2 to the power root log n is less than root n, so it would be at first place. So the answer is none of the above, correct? Let me verify it because I'm not sure why that happened. Oof. It is exponential, but I guess this 2 and log base 2 will cancel out somewhere. So this is the correct order. Okay, so we are good. We just verified it. Okay. For each group of functions, sort the functions in increasing order. So here it is really you can say लालच होता है कि say we see like 0.099999. Here I have 1 million or 10 million like that, right? 1.0001. So you will feel like this function is very big, right? 1 crore n, right? So if I take n equal to 2, it will be 2 crore, like that. So you will think like this function is very big, but it is not, right? Because this c doesn't matter, right? You can choose any c, right? So let's try to solve it, and I guess let's try to solve it. Basically, I don't want to use any shortcut here. So I have some functions like this: f1, f2, f3, and f4. So let's see, let's compare f1 and f2 first. What happened is f1 is n to the power 0.9999 log n, and f2 is 1 crore n, correct? Now what happened is if I take log on both sides, and from this we can directly see like this n is greater than log n and n to the power 0.999. So f1 is less than f2, but let's prove it, correct? So if I take log on both sides, this multiplication would be converted into summation. So log of this is nothing but 0.9999 log n, and log n is log n, right? And what would be the log at this side? So multiplication converted into summation. 1 crore, it would be converted into log 10 to the power 7. I am just writing it 10 to the power 7 log n. So this is constant, we can remove it, right? And this is also constant. Sorry, not this much. So this is, but see, this is 0.999 in log n. This is 1 log n, right? So here it is 0.999 and here it is 1 into log n. So if I take this term this side, then it would be 1 minus 0.99999. That means 0.00001 log n. And here I have log n, right? Now this is constant, I can remove it. I just remove this constant. So here I have log n and here I have log n. So if you compare log n and log n, then definitely log n is less than log n, right? Is it clear, guys? I'm just removing this constant because this is some constant plus some log n, right? So this doesn't depend on value of n. Whatever the value of n you choose, this would be always constant, right? So it doesn't affect your time complexity basically. That's why we can remove this constant. Now here I have 1 log n, here I have 0.999 log n. So I am just taking this term into right hand side, and I am just taking 1 minus this thing 0.999, and as this is constant, I am just removing it. Correct, and I am comparing. So if you think intuitively without removing it, I am comparing the function log n with the function log n, right? Because these two depends on n, and if you compare these two, log n is small than smaller than log n. Correct. Greater.
Mayur,
Yes.
Mayur, how did you move that 0.999 log into the right hand side?
It
There
is
is
like
no
this.
equality sign in between, right?
It is something like this. 2x plus log x is, let's say, less or equal to 5x plus
But
x
that
square.
is true only when there is equality sign, right? So when
See, we are comparing these two, no, and we don't know about equality actually. And you can take equality. Now, what will happen if I assume this is less than, and at last, sorry, if I assume it is less than, at last it is also proving to less than, then I know that my assumption was right. Right? In mathematics, you can do that. You can assume that this equality is greater than. Then what will happen at last is you will prove that it is not greater than log n. Log n is not greater than log n. That means your assumption was wrong. The answer is less than. Correct. But for simplicity, I'm not taking any assumption. I'm just saying this is equality or in a inequality to be precise, but I don't know what it is. That's why I'm using this sign, question mark. Correct. So we can do everything what you can do in the simple algebra. So you can definitely take 2x here and 5x minus 2x equal to 3x, right? You can do that. Correct.
mm, okay, because what we are doing here is we are comparing the things, right? So if we
Huh. And
just
see.
take out something from the LHS side or RHS side, then
Okay, and see, if you don't feel comfortable, na this that I don't have any equality, why I can't perform this, then let me give you one more intuitive idea. That, see, here right hand side I am having function of n which is log n, right? This is some constant. This you can ignore, right? Now on left hand side I am having log n, right? Some multiplication I am having, right? Plus some other another function log n. Correct. Now what will happen is, one second, how can we arrive at this directly without taking log, one more log? I was thinking about that. uh, so 0.999, so this is less than 1. Okay, now I understood. So if you take the more value of n, this will go down actually. This is less than 1, 0.9999, right? So now what will happen is this log n. So we need to compare this log n with log n, because see, these two are you can say exactly similar term. That's why you can
yes.
take this thing on the right hand side. Let's see the solution, like how they've solved actually.
Okay.
I'm F1 and F2, how they've compared. F1 is order of 0. What is this? F2 is less than F4, F2 is equal to this, n equal to this. Not able to actually decode this. F1 and F2 is not compared anywhere. See, what is this? Okay, so let's move further. I don't know, but this is possible because I have done this like multiple times and this works actually. So let's jump on to like comparing this F2 and F4 now. Let's compare F2 and F4 now. because this f3 is already this 1.001 to the power n, it is already exponential, right? So let's compare f2 and f4 now, right? So if I compare f2 and f4, now what happened is f2 is 10,000 and this is n square, so this constant you can remove, correct? So n is less than n square, or you can even cancel n also. So this is constant time and this is n time, linear time, so f2 is less than f4, right? So you can solve it in so many ways. You can even cancel n here also, right? At that day I don't know like why I don't get that idea, तब पता नहीं कैसे idea नहीं है, but this is also possible. This constant time is less than n, so f2 is less than f4, correct? And that time like this was the first time we were solving this type of questions, right? So that's why I have written everything in detail. Now if every if anyone ask me, I will just do it in two steps, right? So now it is confusing also these steps actually. So now let's compare the last piece of puzzle, f4 and f3, n square and 1.00001 n. So you can argue that this is very small term, right? 1.0001, so this is nearly equal to 1. So 1 to the power n is also 1, but no, it won't hold true. Let's see how. So if I take log on both side, 2 log n, and I'm having n log 0.1.00001. So this is constant, I can remove it. This is constant, I can remove it, right? So I need to compare log n with n. So linear time complexity, logarithmic time complexity. So log n is less than n, correct? So f4 is less than f3, right? So now I know f1, then f2, then f4 and f3. So this is the solution, correct? So the key takeaway is nothing but just write the function on left hand side, right hand side. If you're not able to get the you can say easy function, then just take the log on both side, and and second point, remove all the constant in multiplication or summation, I don't care, right? If you have the same type of term on the left hand side and right hand side, just take this kind of subtraction, right? If you have 2n plus 3n square and here you have 3n cube plus 2n, you can just cancel out 2n 2n, there is no problem at all. Okay, uh, half the assignment is done. Let's jump on to next question, question number 7. Okay, so this type of question, to find the order, we generalized this actually, like in previous live sessions. We have like some patterns, either your this iteration in this loop. See here, this question would be asked something like this: you will be given some loop, while loop, do loop, if for loop or anything. Do while I haven't seen, but while loop and for loop will be given, right? And some variable would be used to terminate the loop, right? There will be one variable, correct? And what will happen is that variable, let's say I, that is used to break the loop, will either increase by 1 like this, some constant value, plus 1 plus 1 plus 1 plus 1, or plus 2 plus 2 plus 2 plus 2, right? Some variable k, and then it would be always in order of n, linear time, correct? Then if your variable value, this value is increasing in multiplication, multiplied by let's say k, then multiplied by k, then multiplied by k, what is the meaning of this? Your I was 1, then 2, then 4, then 8, then 16, like that. If it is in multiplication, then it is all mostly of log of n, right? It can be nested loop, so you need to multiply it by n or n square. It is possible, but this is the core case, right? The smallest case possible, I am just explaining. If it is in the power, let's say power of k, then again power of k, then again power of k, like this, then it is log n, right? Log n of base k mostly, right? So what is this? 2, then I have 2 square, then 2 cube, then 2 to the power 4, 16, right? Sorry, this is wrong. This is wrong. So this is thing. This example is for this thing multiplication. 2 to the 4 to the 8 to the 16 like that. In power, what will happen is I will have, let's say, I equal to 2. Then it will be in power of 2. So 2 to the power 2 would be 4. Then 4 to the power would be 16. 16 to the power would be 256, like this. Right? If it is increasing in power, then it would be mostly in log n. We will prove it. There is no problem. But if time does not permit, then just remember this. Right? So these are some pattern. If it is obviously increasing or decreasing, right? You can write a loop in both way. You can take I equal to 100 and just decrease by 1, 99, 98, 97. It is also possible. You can start from 1, 2, 3, 4, 5, 6 up to 100 like that, right? So it is order of n. I guess the idea is clear, right, guys? And these are the patterns that I have seen. And there would be miscellaneous question also that you need to solve it using logic, correct? So with that in mind, having said that, let's take the question number 7. What is the running time of this function? Define a function n of array. Array is an array. A double R is an array and n is the length of an array. Cool. I is equal to j is equal to 0. Cool. I is less than n while I is less than n. So this loop will run n times basically. While j is less than n and array of I is less than array of j, correct? J equal to j plus 1. So this loop will run n time, correct? But not every time. It will just run for first when I equal to 0. After that we are not saying j equal to n anywhere, right? So this would be order of n. Let me explain it again. Huh. So this is the miscellaneous question actually. So what will happen is, see the I, this way we have two variable I and j. The I is corresponding to outer loop. The I will decide when this while loop will stop running, right? So the I less than n, I is incrementing by 1, right? Plus 1 plus 1 plus 1. That means it is running for n time, right? This loop while j is less than n is running for n time, but it will just run for n time, right? After that it won't run. Why? Because let's say I'm having j equal to 0 and I'm inside this loop. Now what will happen? J equal to 0, 0 is less than n, this will run. J equal to j plus 1. For simplicity, just take this as true, worst case, right? I want maximum run of this loop, right? So this is true. J equal to j plus 1, j equal to 2, j equal to 3, j equal to 4, j equal to n, then this loop will terminate. Now this loop is run for n time only, right? After that it is not running, because I am not saying j equal to 0 inside this loop. In this 3 line I am not saying j equal to 0, correct? So this loop will run n time, then it will stop, then I will be equal to 2. From 1 it will be 2, then this loop will not run because j is already n. Then again it will I equal to I plus 1 3, then 4 up to n. So this is order of n, correct? So in worst case it will run n minus 1 time, so it is order of n, correct? And if I just change this a bit, if I say in this line, in particular this line, if I say j equal to 0, then what will happen? When I equal to 1, this will run n time. I equal to 2, this will run n time, the inside loop. Again it will run n time. So it is nothing but n into n square. So it would be order of n square. I guess the idea is clear, guys, right? Because this was the, you can say, toughest question that we will see, or you can say second most toughest question, second last toughest question that we will see in this time complexity analysis, right? Because there is a catch, j equal to 0 is not given inside this loop, correct? uh, Let me clear this and let's take the next question. Huh. Okay, now I have just one loop, so this is easy one. I should have taken the question number 7 at last, but let's start with the tough one. So question number 8, how many times the following loop will run for the given value of n? So it is nothing but the time complexity they are asking. I equal to 2 while I is less than equal to n. So I is my parameter that will decide when this while loop will break. Print I am printing the I, and I is equal to I multiplied by 4. So directly if there is multiplication, it is always order of log n, right? Base would be, I guess, 4, log base 4, I guess, right? So it would be log n, and we can prove that also. So if I take n equal to I am just having n equal to first 2, right? Then if I take I have taken 4, then 8 and 32 like this. When n equal to 4, let's say, right, this is the loop and I need to decide when n equal to 4, then I is less than n, 2 is less than n. So this will loop run for one time, because here 2 multiplied by 4 would be 8. So 8 is greater than 4, so this loop will break, correct? Getting my point? N equal to, I am taking 4, right? So I is equal to 2, 2 is less than n, so it will run for one time. And here it would be 2 4 ja 8, so I equal to 8, so 8 is not less or equal to 4, so this loop will break here. So it is running for just one time. If I take n equal to, now if I take n equal to 8, then it will run 2 times. 32, it will run 3 times. So it is nothing but multiplied by 4, multiplied by 4, multiplied by 4. So if I take log base 4, then I will get 1 2 3. So it is nothing but log, order of log. And this can be also solved using this method. I don't know why I have used this, you can say, sit method. I don't like this method anymore. Let me put cross. This is not a right way to solve it. Let me show you the right way how to solve it. So here the value of I will increase something like this, 1 sorry, from 2 I am starting, right? 2, then 8, then uh, 32, then multiplied by 4, 128, like this. So what is 2, right? So 2 is nothing but 2 to the power 0. This is 2 cube, 2 to the power 5, like this. This is 2 to the power 7, but this is also the exotius, like this, right? So when n equal to, and see how it is increasing, 1, then this is 2, this is 3, this is 4. So how it is increasing is, say, one अरे यार कुछ तो गड़बड़ है. This is first term, this is second term, this is 2 to the, sorry, problem is here, 2 to the power 0 is 1, right? So 1 to 8, like this. So this is 1, this is 3, this is 5, this is 7. So it is increasing. So there would be something like this, 2 to the power k. At last I will have something like this, 2 to the power k. And when this loop will terminate, when 2 to the power k is equal to n, right? There is some problem here. I am not able to get the correct answer. There is some problem in this approach. But yes, at last I will have something called 2 to the power k, 1, 3, 5, 7, 9. That is nothing but 2k, k 2, this thing, this odd number. So k by, how to represent odd number? 2k, 2k minus 1. Yes, 2k minus 1. So if I and 2k minus 1 is nothing but k, order of k. So if I compare 2 to the power k with n, then if I take log on both sides, then k is nothing but log base n, right? So that is nothing but order of log n, correct? Let's take another example. I don't know, like I mess up somewhere. कुछ तो problem है. I'm not able
No,
to get
but
it.
maybe if you see solution, na, you are right, but you got confused only.
Ah. Oh my god. Yes, 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 yes. I generalized it wrong actually.
Yeah. So like 2 into 4 to
2
power 0.
into multi,
That
2
will be
into 4 to the power 0, 2 into 4 to the power. Okay. 2 1 ja 1, 2 4 ja 8, like this. 2 multiplied by 16. So this is nothing but 4 to the power 0, 4 to the power 1, 4 to the power 2. So it is increasing like this. So my last term would be 2 multiplied by 4 to the power k, right? And n, correct? So this constant. So if I take log on both sides, then you will get k is nothing but log n, correct? But definitely we are not going to use this method anymore, because we know if it is multiplication, it is order of log. If it is exponential, it is order of log n, correct? Huh. We have the next question waiting for us, that I equal to 2, similar I is less than or equal to n, print I, then I is math power I square, right? So it is I to the power 2, right? So the I will increase in the exponential way. That means your order is nothing but log n, because your loop will terminate fast, right? Because your termination variable is increasing rapidly, correct? So now let me try to actually formulate it, because I'm not happy with my performance. So if I now convert my I is first 2, then it is I'm taking square, so 2 square. Then again I am taking one more square, so it is 2 square square, like this. So first it was 2, then it is 2 to the power 2 4, to the power 2 16, like this. Then 256, it is increasing like this. So what would be the my kth term, right? So it would be 2 to the power uh, uh, it is 2 to the power 2, then again so this is 2 to the power 0, so 2 to the power 1, so this is 2 to the power 2, that means 2 to the power 2 1, so it is 2 to the power 2 to the power 2, like this, right? So it is increasing something like this, 2 to the power 8, so it is 2 to the power 2 to the power k. So if I equate this with equal to n, then I need to take 2 time log. So 2k log 2 is 1, so it is log n. RIP. And if I take again one more log, then k would be log n. My handwriting. Yes. Now I got some confidence. Great. How to remove this? Yes. 9. Okay, question number 10. I will just take like some more 5 minutes, maybe 5 or 10 minutes. You are given a set of n points on the number line. They are given in the arbitrary order. The task is to find the points that are closest to each other, right? To solve this problem, you decide to take one point and compute its distance to all other points. Repeat this process for all points. During this process, you take the closest pair. What is the running time of this algorithm? So ये मतलब this is just you can say story. We don't need to fall into the story. What they are saying is you have some numbers, n points, and what you are doing is I am having n points. What you are doing is you need to find out the closest pair. So what we are doing is you are taking the first term and you are comparing with each rest of the term, right? So I am comparing my first term with n minus 1 time. Second term would be compared with n minus 2, right? I don't need to compare with first term, correct? Then I will compare with n minus 3 time, third term. Similarly, my last term, say third last, would be compared 3 time, then 2 time, then 1 time, like this. So this is nothing but 1 plus 2 plus 3 plus 4 plus up to n minus 1. So if you take the summation of all this, it would be n by 2 n plus 1, that is n minus 1 by 2 n plus 1. So n minus 1 plus 1 would be n. So if you take the multiplication, the term you will left with n square by 2 minus n by 2. So it is order of n square. This is the answer, correct? And this solution is not you can say good. N chose 2. I don't know how they come up with this. Okay. So we are comparing actually basically two random 2 points, no? So we can use this formula. Yes. Question number 11. Consider the following chord segment. Assume n to be positive. Integer I is equal to this. Let t of n represent this total running time of the segment. Which of the following statement are correct? Right? Okay, so we need to find out the complexity only. And here we have one hint that 1 plus 1 by 2 plus 1 by 3 plus 1 by 4 up to 1 by n is order of log n. Right? Basically, it is log n, nothing else. Right? So let's see how we can use that. So what is the how many variable we have? I and j. So we have just two variable. I is initiated here, j is initiated here. Okay, that's fine. So while I is less than equal to n, so this loop will run n time, right? I don't know like what is the answer, but let's try to solve it if we can solve it in less time. So this will run n times. That's fine. Now j is less than n, so this will also run n time. Correct. Now what they are doing is okay. This will not run for n time. Okay. There is a catch. So j is not equal to j plus 1. J is nothing but j equal to j plus I, right? Now okay, that's fine. So we need to calculate it. We can't use the sort tricks here. And I is equal to I plus 1, so here it is fine. So this will this loop will run for n time, that's for sure, right? So our complexity would be n multiplied by something, right? N multiplied by something that we need to find out from this loop. Correct. So the half work is done. If you think intuitively, the A cannot be the answer, D cannot be the answer. The answer can be either B or either C. Correct. So now let's find out what is the answer and how can we work out this example. So it is nothing but you just need to track the value of j here, how many times this loop will run for each iteration. I equal to 1, then I equal to 2, then I equal to 3, like that. So let's see where it is. Question number 9. Which question it is? 12, no? 11. Okay. So now what will happen? If I equal to 1, then what will happen? J will increase by 1, 1, 1, 1, 1, like that. Correct? So this loop will run for I time, n time. Right? I equal to 1. Then what will happen? N equal to 100. Then this loop will run for 100 time because J is increasing by 1. When I equal to 2, in the next loop, when I equal to 2, then this loop will run for n by 2 time. If you take the example, then j is increasing by 2, right? So j would be 1, then 3, then 5, 7. So it will run for just 50 times. It is nothing but n by 2, right? When I equal to 3, it will run for n by 3. And when I equal to n, then what will happen? It will just run for 1 time. Correct? So if you take the summation and here we need to use this hint. So if you take the n common, then what happen is 1 plus 1 by 2 plus 1 by 3 plus 1 by 4, and this 1 would be 1 by n, right? And this is given as order of log n, right? So this is nothing but log n basically. So n multiplied by log n, so it is nothing but order of n log n, correct? And what mistake I did is I found out this complexity order of n log n, and what I did is I just multiplied with this n times, right? So it would be n square log n, but that's not right because we are counting all this iteration of I, first, second, third, all n iteration we are calculating the time, right? So the answer is n log n, not n square log n. Correct. So that was the mistake that I did here. Last but not least question. Okay. Just a second, okay. Let me have some water, then I will finish it. It's 11:30, but I am taking it for granted that everyone is engineer here. Okay. So I have some functions n to the power root n, 2 to the power n, and third function is n to the power 10, 2 to the power n by 2. So everything is looking like exponential. The last function is given in this form, that sigma I to the I 1 to the n I plus 1. So we can convert it into this form, n square by 2 3 by 2 n, like this, right? Correct. So this is order of n square or theta of n square, right? So let's compare f1, f2, f3 and f4 one by one, right? Okay, let's compare f4 and f1 first, right? F4 and f1, because it is looking like n to the power something and n to the power something, like this, right? So let's compare f4 and f1. F4 is n square, f1 is n to the power n root n, right? So from our knowledge base, we can directly say f4 is less than f1, because this is n to the power root n. Root n is greater than 2, right? 2 is constant, root n is function. So directly we can write this, but if you want to be sure, 100% sure, then just take a log on both sides. So it would be 2 log n, here it would be root n log n, correct? So this log n and log n will cancel out, so I need to compare 2 with root n, right? So if I compare 2 and root n, f4 is less than f1, as easy as that, correct? Let's now compare this thing, f1 and f3. So f1 I am having again n to the power root n, and here I am having n to the power 10, 2 to the power n by 2, right? So let's see how can we solve that. This is not a really easy task, but let's try. So I will take first log, right? So this would be root n log n, and this would be this multiplication would be converted into summation. If I take log of this, it would be 10 log n. If I take log of this, it would be n by 2 log 2. So n by 2 log 2, this is 1, right? Now I can take 10 log n here, right, and take the this you can say subtraction minus, and if I take root 10 minus 10, so root 10 minus 10 into log n, and in right hand side I am having just n by 2. Now let's try to compare it and see, this is constant, right? Whatever the value of root n I will take, this minus 10 I am just taking the subtraction of this minus 10, right? So I can definitely ignore this 10, right? Now what happen is, and why we are having this term? Okay, I'm just trying to explain why we can remove this. Because see, root n minus 10 log n can be written as this, root n log n minus 10 log n. So as the value of n will change, this will change very slowly, and this will change rapidly, correct? Root n log n will change very rapidly compared to this. So this is order of root n log n, or you can say theta of root n log n. So what we are basically comparing is root n log n. I can neglect this 10 and multiply root n into log n. So root n log n, and right hand side I am having n by 2, and n by 2, this 1 by 2 can be 1 by 2 multiplied by n, right? So 1 by 2 can be also neglected, right? So don't care about that constant term. So if you compare root n log n and n, right, and see, now you can directly write that this n is greater than root n log n, or you can also simplify further. So this n is nothing but root n multiplied by root n. So what I am doing is I am just cancelling this root n with this root n, right? So log n, and I need to compare with root n. So log n is always less than root n. From the order of function we know this, right? Logarithmic, then c less than 1, n to the power c, then polynomial, sorry, n, then log n, then polynomial, right? So f1 is less than f3, correct? So the key takeaway would be like whenever you have some function, and you can always like its order, right? Big O or theta, right? You can write omega, you can write big O or theta, because this term will only matter, this 10 would not matter at much, right? Because this will be like very much less than this term, correct? That's why this is a hard question. Now it is trivial, now everything is very easy. Now let's compare f3 and f2 now. N to the power 10 to the power n by 2, 2 to the power n. So basically I will just take log, boring stuff, just take log and it will be clear. So multiplication into summation 10 log n by 2, n by 2 log 2 is 1, and here I will have just one n, right? Now this is constant, n can be neglected, and n minus n by 2 is nothing but n by 2, correct? So now log n is less than n by 2. That means f3 is less than f2. So from equation 1, 2 and 3 you can write this answer: f4, f1, f3 and f2, correct? And Professor Khalil, as an exercise we will take it tomorrow, because we have like some 8 to 10 question from asymptotic notation. Then it will start directly into this thing, uh, that recursion part, right? So tomorrow we will start with the recursion, how to solve that recursion problems. Where it is, this thing, how to solve this, right? This recursive formula, the recursive functions, correct? We will try to use this tree method and back substitute method one by one, but mostly I prefer back substitute method, because sometimes this tree method is you can say complicated. Any questions, guys? I hope you are not sleeping.
No, Mayur, we're good.
I'm just joking.